everyone, and welcome to the second episode of our calculus series. And in this video, we are going to be talking about some of the rules and the formulae that are fundamental to differential calculus. So moving forward, actually before we dive into the video, there's something that I have to talk about, and it's the definition of a derivative. Now, previously we've learned that the formal or the actual definition of a derivative, for example, f dash of x, is the limit of f of x plus h minus f of x over h as h approaches 0. Now, this is the formal or the actual definition of a derivative. Now, this is going to be very important in this video as well as throughout our entire series, because we are going to be using this very definition of a derivative in order to derive all the different formulae. So I want you guys to keep this formula in your minds. And yeah, so we are going to be using this definition of a derivative in order to actually derive stuff. So let's jump into the video now. So rules and formulae that you will be needing in order to master differential calculus. The first rule is something called the power rule. Now, the reason it's called the power rule is pretty evident because it deals with a function having some sort of an exponent, having some sort of a power. So it's called the power rule. Now, this rule is essentially, it's pretty straightforward, and I think I'll actually derive the rule as well. So we have that f dash of x is equal to nx to the power of n minus 1. This is what we need to derive. And we have f of x is equal to x power n. So we will be using this formal definition, or this definition that we have stated will be important in order to derive this term over here. So using that definition, we can say that f dash of x is equal to limit of f of x plus h minus f of x over h as h approaches 0. Now, this is equal to, so f of x plus h is just x plus h power n minus, and this term is just x power n over h. Now, this is going to be a very crucial step right here. What I'm going to do is, if you recall what we studied back in calculus, or rather especially in limits, you'll remember that this approaches sign essentially functions as something like an equals sign. So if we add x to both sides, then this is the same thing as, well, this. So we can add the same terms to both sides. So it's something like an equals sign. You could think of it this way. So what I'm going to do is just the same that I did over here. I'm going to add x to both sides. So x plus h approaches x, and x plus h approaches, x plus h power n minus x power n. And on the denominator, I'm going to do something very important. What I'm going to do is I'm going to add x like so, and also subtract x. So essentially speaking, these two denominators are the same thing, and these two limits, these two parameters of the limits are the same thing. So this is equal to that. And now if you notice, you will see a specific pattern in this. And the pattern is something that you all have already seen if you have studied some limits. So you might be familiar with the formula that goes something like this. And this is the exact formula that we're going to be implementing over here. So if we implement this formula, we are going to get nx power n minus 1. So we've essentially derived the power rule. Now the derivation of each of these rules is not going to be possible in this video because it's going to be fairly lengthy. So, and the thing is, you can derive all of these just using the definition of a derivative, which is over here. So I think you should try these. Before that, I think you should finish watching this video as I introduce these rules. So the first rule has been made pretty clear. Now, as for the second rule, so this second rule is essentially for a constant k times a function. So if we have a function, let's say f of x equals 3x squared. Now, what the second rule says is that, if we take the derivative of f of x, well, essentially speaking, this itself is also a function. Let's say that gx is equal to x squared. Because of this, you can write fx as 3 times gx, which means using the second rule, we have that this is equal to 3 times the derivative of gx with respect to x. So this is what the second rule states. It states that if we have a constant before a function, we can essentially pull out that constant before the derivative and just take the derivative of the function. So it's a pretty straightforward rule, and moving forward, this is the sum or the difference rule, which states that if we have the sum or if we are taking the derivative of the sum or the difference of two functions, then that will be equal to the sum or the difference of the derivatives of each of those functions. So if we have a fx plus gx over here, we are going to have d of dfx over dx plus dgx over dx. This itself is also a pretty straightforward rule. You could say that this derivative operator is commutative for addition and subtraction. You could essentially interpret it that way. However, the same is not true for multiplication. Now, in multiplication, this is called the product rule. In multiplication of two functions, if we're taking the derivative of the product of two functions, then we are going to have, let's say, if these two functions are fx and gx, we are going to have that this is actually equal to fx times the derivative of gx plus gx times the derivative of fx, all with respect to x. Now, after that, we have something called the quotient rule. Now, this rule is pretty different from both number 3 and number 4 because the order of the function over here and over here did not matter. So you could essentially write it as gx into fx and apply this formula, which would be correct. And the reason that it's different is because unlike these two, the order of the functions actually matter. So if u and v are two functions, then the derivative of u over v is going to be v times du over dx minus u times dv over dx, all divided by v squared. This is called the quotient rule. After that, we have something called the chain rule. So the chain rule. Now, this is a very important and very useful rule in differential calculus. And what this essentially states is that if we have some sort of a derivative, let's say dz over dx, we can write this as dz with respect to anything, let's say dA. And we have to multiply this by another derivative which has dA in the numerator and which might have anything in the denominator, let's say dB. Now, this goes on and on for as many times as you like until you reach something like, let's say there's something over here, and it's divided by dw times dw over dx. So notice that all of these functions function as some, you could say that it functions something like a fraction, right? So you could picture, cancelling each one of these, and you will obtain dz over dx quite easily by doing this. So it's pretty trivial to think of it this way, but the formal derivation for this can be done using the definition of a derivative. And the reason this is important is because let's say that we have something like dy cubed over dx. Now, we are unable to take this derivative directly, right? Because we do not know, because we do not have this as dy. If we had it as dy, let's say dy cubed over dy, we would have that this is equal to 3y squared. However, that is not the case. So now what we do is we use the chain rule in a way that enables us to differentiate. So instead of writing dy cubed over dx, we write this as dy cubed over dy times dy over dx. Now this is equal to 3y squared times dy over dx. This is how you obtain the derivative of functions such as this. So that was the use of the chain rule, and these are pretty much the most elementary rules that you kind of need to know in order to understand differential calculus properly. And these are just the basic rules. Everything that you do in calculus, just the basics, is built upon these rules. So for example, if I give you a question such as the derivative of, let's say, 3x cubed plus 2x squared plus r, where this one is a constant, you should be able to find it out. So I'll leave this one as an exercise. Besides this, I'd also like you to try something like, let's say we have two functions, gx, which is equal to 3x squared over 2 plus 1 over x. And the other one is h of x, which is equal to 7x squared. So let's make this a bit interesting. Instead of writing 7, I'll write pi x squared, which is, of course, the ratio of circumference over diameter, the constant pi. So let's make it a bit interesting using this. And I want you to calculate the derivative of gx times hx. So I'll leave this question and this question as an exercise, and this should be pretty simple in my opinion, because these are very elementary questions. And the thing with calculus is you yourself could make different questions, for example, using these. So for example, if I have this as gx and this is hx, I could also ask you to find dx of, let's say, hx over gx. So this could also be a plausible question. So I'd like you to try these different questions out. And yeah, I guess that will be it for this video. I hope that you understood what I said. These are very elementary rules, so it shouldn't be too much of a problem for you to understand intuitively. So yeah, so that was it. I hope you enjoyed this video.